Hello, everyone, and welcome to today's class on calculating economic order quantity. I hope you're doing well. This class is a follow-up to the inventory management class or lecture that I gave. And during that lecture, we learned a lot about inventory. We learned about, the costs of carrying inventory. We learned about setup costs of inventory. We also figured out that, holding inventory is a very big issue for companies. And there are a lot of questions that, organizations have regarding how much inventory they should order. And so, there's so many factors that need to be considered in terms of how much they should order. And so, thankfully, in supply chain management, there is a very powerful economic model called, the EOQ, or the economic order quantity. And this basically, it shows how you can balance various costs of stocks, of inventory, or all the various costs involved in inventory management. And it will basically give you exactly how much quantity you should order. So this is basically, it's an approach to build a model of an idealized inventory system, and it calculates the fixed ordered quantity that minimizes your total cost. So again, a company could consider just keeping a whole lot of inventory, right? Like a million boxes of inventory. But if they do that, then they're going to have a very high amount of inventory holding costs. So that doesn't really make sense for them. And if they order a very, very small amount, then they're going to have to make many, many rounds to the supplier. And there are going to really be so many transportation costs and setup costs and order costs. And so the question is, how much they should order, right? Not too much, obviously. That, as I mentioned, that's not the answer. And ordering too little is not also the answer. So it has to be somewhere in the middle. But again, how much is the question. And so thankfully EOQ helps answer that question. And the EOQ, at the EOQ quantity, that's where the total cost of inventory is going to be the minimum amount. Anything, if you order more than the EOQ or less than the EOQ, it will not be your minimized total cost. It will be higher than the cost of EOQ. If we kind of just look at this graphically, or on this slide, we can see that there's inventory on hand and there's a timeline. And so a company is going to keep some safety stock, and then they're going to order an EOQ amount. And over a period of time, this EOQ inventory amount is going to reduce and deplete. And then at a certain point, they're going to have to reorder the EOQ amount, and then it keeps on going down. And this up and down process of inventory is also known as cycle stock. But the big question again is, how much? And so thankfully, EOQ is going to be, it answers that. All right, next I'm going to talk to you a little bit about calculating the economic order quantity. Okay, so as I just mentioned, for any company, there are some holding costs or carrying costs. And just to remind you what those holding or carrying costs are, they're basically costs of storage. So imagine if you're holding, and the holding costs, or you're holding a lot of stock in a warehouse, then in that case, you're going to have to pay for the warehouse rent. You're going to have to pay for the electricity of the warehouse. You're going to have to pay for labor to go and check the inventory regularly. Perhaps you're going to pay some insurance costs, and you might have to pay taxes, right, on all the inventory that you're holding. So these holding costs increase as the amount of quantity that you hold of inventory increases. So If I have just 100 pieces of inventory, I need a very small warehouse. But as the amount of inventory increases, I will need a bigger and bigger warehouse. And as the warehouse size gets bigger, my holding or costs are going to be, holding or carrying costs are going to be increasing. And so you can see a direct, sort of increase going on at a steady rate, over a period of time of the holding costs, right? All right, now, on the other hand, as far as ordering costs, so let's say I need to get some orders from China. Now, if I order a very small amount, my order cost is going to be very high. So perhaps the factory in China is going to say, well, if you just want very few units, we're going to charge you a high price. But on the other hand, if you give us an order of a very, very big size, then we will give you quantity discounts. So the bigger order that you give us, the lower price we are going to charge you. And again, even with my overall costs are basically going to go, my ordering costs go lower as the inventory quantity increases. So you see that on one hand, the holding costs are increasing, but the ordering costs are decreasing. Now, interestingly, there is a point where both the order cost and the holding cost merge, or they cross each other, right? And they intersect. And so this point of intersection, where, again, the holding costs are intersecting with the ordering costs, this is 400 in this case. This is my economic order quantity. And at this point, the total relevant costs, right, of my inventory are going to be at its lowest. So that's why EOQ is, if you look at it from this sort of picture, it really makes a whole lot of sense, right? But the thing is, it's sometimes very difficult to sort of put everything on a graph and, see the point of intersection and calculate it. So, there's a lot of theory behind this, and, there are some economic, there are actually some formulas. And if you apply those formulas, that's going to be able to automatically calculate the EOQ, right? Okay, so before I go into the formulas, there are a couple of notations that I do want to mention, because these notations you will be seeing in the future slides. And when we are going to start solving the EOQ questions, you'll definitely need to know these notations. All right, so I'll go through each one of them. D stands for average demand. The important thing for you to know about the demand is that you need to calculate the yearly demand. So some questions in EOQ really can trick you up a little bit, because they may say the semi-annual demand is 10. Well, the average semi-annual demand is 10. Well, then you can figure out from there that the yearly demand, the average yearly demand is going to be 20. And so you'll need to use 20 for D. So again, it's always the average yearly demand. C is the cost at which you are purchasing, right? So it's the cost that you are going to be purchasing something from the market. It is a purchase cost for you, what you're buying, goods that you're buying from the market. CT is the fixed order cost. So this is, per order, what is the cost? H is usually a percentage, and it is a percentage carrying or holding charge. CE, now this is very important. CE is taking C, the variable purchase cost, and multiplying it by H, the carrying or holding percentage. And this basically gives you the excess holding cost. Next is Q, and Q stands for EOQ. And so just remember that Q is EOQ. T is the order cycle time. So after how many days should you place an order? N is the inverse of T. So it's 1 over T. And so this will give you the orders per time period. TRC for Q, in brackets, Q stands for the total relevant cost at the EOQ. TC brackets Q stands for the total cost at the economic order quantity. Okay, so this is the formula for calculating EOQ. So again, it's, Q star is equal to square root of 2 multiplied by CT multiplied by the annual average demand divided by CE. And as I had mentioned on the previous slide, CE is basically C into H. So the variable cost multiplied by the H, which is the holding or carrying cost percentage. Please note that I do not expect you to memorize these formulas. I will be providing them on your any exam or any quiz. So all you'll need to do is plug them in. But you do need to understand how to plug them in and what formula is used where. All right, so again, EOQ, this formula was mentioned in the previous slide as well. Now T, okay, T star. So how often should you be placing an order? Let's say after how many days? So this is T star is the EOQ, Q star divided by D. And this will give you T star in per year. So you will, if the question says in days, then you will need to multiply T star by 365. If it says in years, then you just give T star. If it says in months, then you take T star and multiply it by 12. Another way to calculate T star is using this formula. 2 into CT into D divided by D squared into C into H or CE, and you take the square root of that. And even for T star, this was one formula, but there is yet another formula, which is this. T star is equal to 2 into CT divided by D into CE, which is also C into H, and you take the square root of that. One thing to note here is that if you'd like to calculate N, which is how many orders should be placed in a year, you basically take the inverse of T star, and so it is 1 divided by T star. On this slide, you see the formulas for total cost and total relevant cost, right? And they're pretty much the same formulas, except what you'll see is that over here in the total cost, you have purchase cost, order cost, and holding cost, plus the shortage costs. And so, but in the total relevant costs, you don't have purchase cost, but you do have the order cost and you do have the holding cost. And so it's only the total relevant cost is just, just these two sections, the order cost and the holding cost. It does not include the shortage and it does not include the purchase. Also, I do want to mention that in most of the questions, shortage cost is not included. Also, just please note here that CE is both mentioned in the total cost formula and the total relevant cost formula. And as I've mentioned previously, CE is basically C into H. On this slide, there are just some additional formulas for total relevant cost and for total cost.
So again, you know, it's your choice, whichever formulas you're more comfortable working with. All right, next up, I'm going to take you through an actual question, and we will solve EOQ in this question. So the question says, find the optimal order quantity, inventory policy, and total relevant cost for a product with the following characteristics. Demand is 2,000 units per year. Cost of placing an order is 500. Cost of product is 50. Holding cost is 25%. Selling price of a product is $75 per unit. Please note that usually selling price is not needed to solve EOQ problems. Okay, so if I look at this question, the first thing I will figure out is that cost of placing an order is CT. So before that, I'll look at the demand. It's great. It's in per year, so I'm fine with D. I'm going to, figure out that, okay, CT is going to be 500 in this for this question. Cost of the product is going to be C, 50 per unit. Holding cost is going to be H. So that's, 25% or 0.25. Now, all I need to do now that I have identified what everything is plug it in to the equations. And so 2 into 500 into 2,000, and I divide it by C, again, 50 into 0.25, and then which is 12.5, and I take the square root. And that is going to give me 400, which is the EOQ. Now, once I have the EOQ, I can figure out the T star. And so what I can do is take Q star, which was EOQ 400, and I divide it by the average annual demand. And the average annual demand was 2,000. So I take 400 divided by 2,000, that gives me 0.2 years. If I take 0.2 years and I multiply 0.2 into 365, that gives me 73 days, which basically in essence means that I should be ordering the EOQ amount every 73 days. Now, if I want to know how many orders I'll be placing in a year, I take the inverse of T, and basically I say, 1 over 0.2. Another way of doing this would be, D over Q star, which will be 2,000 over 400, and that will give me 5. So I will know immediately that I will be placing 5 orders per year. Next, as far as calculating total relevant cost and total cost, again, I basically just plug it into the formulas. There are 2 sets of total relevant costs and total cost formulas. They should both work for you. And I would strongly suggest that you try them both out. They'll give you the same numbers. So again, if I plug in all the numbers in the TRC formula, that's going to be 2 into CT is 500. CE is C into H, which is 12.5. D is 2,000. I take a square root of that, and the total relevant cost is going to be 5,000. The total cost is going to be the purchase cost, C into D, plus the TRC. Again, this is just a moderated way of showing you. If you recall, it's, the only thing missing or difference between the TRC and total cost, the total relevant cost and total cost is that there's an element of purchase cost that's added on when you're calculating the total cost. So if you add that on, the total cost will come to 105,000 per year. So again, if you want to answer the question, you will be ordering an EOQ is going to be 400. So you will be ordering 400 units, and you will be ordering 400 units every 73 days. Now, next up, I will be talking about sensitivity. And so the whole idea behind EOQ sensitivity is that if the quantity is a little bit above or below the EOQ amount, and you want to figure out how much this is going to impact your total relevant cost, then what you do is you calculate the EOQ sensitivity. Again, I'll repeat that. If the amount of quantity that you are actually ordering is different from the EOQ amount, and you want to see how much of an impact that's having on your total relevant cost, you would be calculating the EOQ sensitivity. And I will show you how that is done. So again, if you use the wrong order quantity Q, not Q star, but Q, some other wrong quantity, how much worse will my total relevant costs be by using the wrong Q versus Q star, which is EOQ? So the way you calculate this is you basically take, the formula is half or 0.5 into EOQ divided by the wrong quantity that you ordered plus the wrong quantity divided by EOQ. And so you plug it in and you will be able to figure out the EOQ sensitivity. Now on this slide, the point that they're trying to make here is that if you really look at the total relevant cost at various Q values, the order quantity is different, right? Well, the total relevant costs are going to be the lowest at the Q star or EOQ amount. And so long story short, you can plug these quantities in using these values and calculate the ordering cost, the holding cost, the total relevant cost. And you will find that most definitely over here at EOQ, that's going to be your lowest point in terms of total relevant cost. So that's the point, that's the amount that you want to really order. But again, if you want to find out how much of a difference there is from in terms of total relevant cost as compared to these other values, you can basically figure that out over here, right? So there's a 200% higher in the total relevant cost over here. Sorry, 125%. If you, in terms of TRC over TRC star, if you look at Q over Q star, it's 200%. So again, long story short, you really want to order at the EOQ quantity. Now, if you also want to go ahead and figure out how sensitive the total relevant cost is to changes in demand, you can use this formula over here. So again, if the demand is changing, then what kind of an impact is that having on the total relevant cost? You can plug it in over here in this formula and you'll be able to find out. How sensitive is the EOQ with regard to order cycle time? If the order cycle time is changing, it's not T star, but you decide that you want to order it a little bit earlier, a little bit later, then what kind of impact is that going to have on your total relevant cost? That's again something that you can figure out by plugging into this formula. I now want to talk a little bit about some of the model EOQ model assumptions. There are a lot of assumptions for the EOQ model. Some of the most important ones are that demand is considered to be uniform and deterministic. So you can easily determine what the demand is going to be. It's considered uniform. So there's not a lot of increase or decrease. It's considered stable. Lead time is instantaneous. So as soon as a customer places an order, the model basically assumes that immediately it will be delivered to the customer. And the total amount that is ordered is also received. So the amount that whatever the customer orders is also going to be the same amount that they receive. So if and when a company is actually thinking about using EOQ, it won't work in all situations. There are, this model just as it is, um, really takes a lot of things for granted, such as demand being constant. Now, usually demand is not constant for companies, and that demand is always known, it's continuous, lead time is instantaneous. Usually there is more of a lead time. It's very rare that, as soon as a customer orders something, they will receive it. Um, and so it's, it doesn't work for perishable goods. That's another thing. And so, you know, one couple, these are things to really take in consideration. So there are moderated or different versions of the EOQ that are available for different situations. So for example, if there is a company that has seasonal demand, there is a variation of this formula that those companies can use. So various moderated versions of the EOQ do exist, but I just want to be very clear that if a company is using exactly this model, which is a very you know common model for EOQ, then these assumptions have to be made sure that they actually apply. So it's only if these assumptions apply should EOQ be used. So with that, I come to an end to this lecture. I will be giving practice questions. I mean, the main emphasis that I would really like all of you to focus on is how to calculate, EOQ, T star, N, the total cost, total relevant cost. Those are the key things that I really, really would like you to focus on. Not so much on the sensitivity. I would like you to have a basic working knowledge about, how the sensitivities work, and that you can calculate, sensitivities of EOQ and their impact on total relevant cost. But I really don't, that's not what I really want you to emphasize on. This lecture will be followed with a whole lot of practice problems, and hopefully you will get more and more comfortable with EOQ once you do those practice problems. Thank you very much.